Explore more about the topics you love with Toppr. Subscribe now and keep learning.
Hello students, in this session we are going to solve a problem based on dimensional analysis. We will see how we can encounter this type of problem. It has been asked to derive dimensionally that S equals to ut plus half at square. Now it contained two factors, that's ut plus half at square, right? And these two factors are independent, right? So let us first try to solve this problem with the help of the dimensional analysis or the way that we have solved in the last problem. So from the expression it is obvious that S depends on three factors. One is initial velocity, one is acceleration, another is time. So let us first try to write it in terms of the product of these three terms with their respective powers they are raised of, right? So let us first write displacement or S is directly proportional to, for example, let us say u to the power x, a to the power y and t to the power z, right. So you have written u to the power something, a to the power something and t to the power something in the product form, but the expression is not saying so. It has some product form plus another product form containing at, another product form containing ut, but they are added. So let us try to face or let us try to experience what are the shortcomings that we have to face if we solve in this way, right. So as we know that displacement has got the dimension of length. So length to the power 1 is equals to u has got dimension what? Velocity means length per unit time, that is L t to the power minus 1. So length t to the power minus 1 raised to the x. What is the dimension of acceleration? It's L t to the power minus 2 raised to y, and time has got acceleration, the dimension t raised to the power z. Now just try to observe in this particular expression there is no mass, right. So I can write, just add an additional term, that is t to the power 0. Now the similar way let us try to segregate the power of length and the power of time, right. So L to the power 1 t to the power 0 is equals to, if you see, L to the power x from this part and y from this part, right, and t will be t to the power minus x minus 2y plus z, right. Now we will just compare the power of both the sides. So comparing power of both sides, what we will get if I compare the power of length, x plus y equals to 1 as equation number 1 and minus x minus 2y plus z is equals to 0. This is equation number 2. Now see, in these two equations we are having three variables. We have to solve for x, solve for y and solve for z, but the total number of equation is 2. So this is physically not possible, right, because the assumption that we have taken at the beginning that displacement is directly proportional to the product form of u to the power something, a to the power something, t to the power something is wrong, right. So this type of problem, or to derive the equation for something which contains two independent factors with the and related by the summation of that two factors, we'll have to solve this in some different way, right. So in this way it is not possible. So physically not possible, right. So let us try to solve this problem in some different way. Now as you can see from these two terms, one term contains initial velocity and time and another term contains acceleration and time. So at first we will assume that let acceleration of body be 0, right. So if the acceleration of the body is 0, then we can write that displacement is directly proportional to, let's say, u to the power x and t to the power y, because it is no more depending on acceleration, because acceleration is 0. Or we can write it as, let the constant be s, let the constant be k1, s equals to some constant k1 into u to the power x, t to the power y, right. So again, let's follow the same path, that the dimension of s is L, which is equal to dimension of velocity, that is L t to the power minus 1 raised to x, dimension of time, that is capital T raised to y, right. Here I can write again that t to the power 0, L to the power 1. So if I just capture the L in the power of L together, so I can write L to the power x and t to the power minus x plus y, right. So again we will compare the power of both the sides. So for t I can write minus x plus y equals to 0, this is equation number 1, and for the power of L I can write that x equals to 1, this is equation number 2. So we already came to know that x equals to 1. So if I put this over here, I can write y equals to x, that is equals to 1. So u to the power 1, t to the power 1 into k1 will give you s. So I can write s equals to some constant k1 into ut, right. Now let us assume that initial velocity to be 0. Let body have initial velocity equals to 0. Now if the initial velocity is 0, then we can just assume s is directly proportional to a to the power p into t to the power q, because it will no more depend on initial velocity, because you have already assumed it to be 0, right. Or you can write s equals to some constant k2 times a to the power p, t to the power q, alright. Again let us follow the same way, L to the power 1, t to the power 0 is equals to the dimension of acceleration, L t to the power minus 2 to the power p and t to the power q, right. That is equal to nothing but L to the power p and t to the power q minus 2p. Let us again equate those things. So p will be equal to 1 and q minus 2p equals to 0. From here we will get what? Q equals to 2p or q equals to 2, right. So from this expression I can write s equals to that constant k2 into a to the power 1 or a and t to the power q means t square. Now see, s depends on ut via constant k1, that is dimensionless, and s depends on a times t square via constant k2, that is also a dimensionless constant, right. So experimentally it has been found that k1 equals to 1 and k2 equals to half, right. So it depends on both ut, product form of ut, and at square. So I can write by combining, by using these two constant, s equals to ut plus half at square, right. So this is the way how we can derive a particular mathematical expression that has got two independent factors in their product form. So student, this is the way how we can derive dimensionally different equation on the basis of their dimensions.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.